Hello everyone. So my name is Satyam Raha, and in this video I'm going to explain the concept of logistic regression. So what is logistic regression used for? It is basically a classification technique. You know, right? There is classification, there is regression, and there is clustering, right? So logistic regression, although the name has a regression, still it is a classification technique. So first point is it is a classification technique. Okay. uh, so we'll just derive the equation of logistic regression, basically how it works behind the scenes, because in machine learning, in scikit-learn, whatever package we already have the logistic regression, knn, this decision tree, naive bayes, k-nearest neighbor, all those algorithms are already implemented, right? But if you do not know how the actual algorithms work behind the scenes, you will not be able to use it right in the correct way. So let's see the geometrical intuition behind logistic regression, how it works, right? So you will need the basic concepts of linear algebra. You see, let's say we have some positive points and we have some negative points, right? So let's say we want the example as a binary classification problem. So there are positive points and there are negative points. Let's say so for example we have yi's as let's say +1 and -1, for example. That means yi means what is yi? So I'll talk about xi's and yi's, right? So as you know, that classification is basically supervised learning, right? That means you um, already have the independent variables as well as the dependent variable data already provided, right? The training data already has the independent variable as well as the dependent variable. Here yi is the dependent variable, and is basically the independent variable. So for example, let's say xi's contain, let's say, height and weight. Okay. And let's say yi is some level, let's say gender, for example, although it doesn't make any sense. Just a second. So let's say, okay, let's not take this height and weight, it doesn't make sense at all. So let's say an attribute a and attribute b, and let's say this is a class. Okay. So basically this is your training data, right? And here what you will be provided is see, a and b are two features, right? It can be height, weight, it can be anything, right? Anything basically. So and a class is basically whether this is a positive class or a negative class. Here we are assuming in logistic regression that the positive class will be denoting it with +1, and a negative class will be denoting it with like -1, right? So how do you see an example here? You see, for example, we have let's say a's and b's. Let's say we have some values, right? Let's say we have 5, 6, 2, 3. It doesn't matter. This is just some a random example. Let's say this is class 0, this is class, sorry, no, class 0. This is basically class +1 and -1, right? So let's say we have something like +1, -1, +1, likewise. So these will already be provided, right? In your training data set, we already have it leveled. The classes are leveled, as you know, supervised problems. So now here a and b are the features, right? Are the independent variables, and they are actually the xi's I'm talking about, and yi is basically the class, the target variable, right? The dependent variable which is dependent on the independent variables. So this is what we need to predict, right? What is a class? What is a class given some a b values? So this is a prediction problem, right? So let's say given some features of a dog or a cat, I need to predict whether it is a dog or a cat. Say for dog we have +1, for cat we have -1. So given the features of the dogs and cats, let's say the size, let's say the color, let's say some ear size, let's say some nose size, whatever it is, depending on some n different features, we want to predict what class it is, whether it is a dog or a cat. So given such kind of training data, what we need to do is we need to build a model, right? We already know that we need to build a model, and that model, when I want to predict something, let's say now an animal has come, and now I know its features A and B, and I'll be providing that A and B to that particular model, and it will say whether it is a dog or a cat, right? So this is our basic problem. Just in logistic regression, we are assuming that the positive class is +1 and the negative class is -1 and not a 0. Okay, normally in other algorithms we use 1 and 0, positive class and negative class, 1 and 0. But here, for some reason which you'll be understanding later, we'll be using +1 and -1, right? So let's not waste much time, and let's formulate the problem. So here you see we have +1 as -1, we have xi's and yi's already provided. Now let us assume that there is a plane, and we have some positive points over here. So these are some positive points, and let's say we have some negative points over on the other side of the plane or a line. Let's say this is a plane called pi. In 2D it will be a line, right? In n dimensional space it will be a plane. So so here are some positive points, some negative points, and we can have like this also, right? We can have a mixture. We can have some negative points on the positive side, or we can have some positive points on the negative side, and that is the real scenario. Now what happens behind the scene? You see, what is these positive points and negative points? So what I'm talking about is the features of a dog will be different from the features of a cat, right? Or the features of a male will be different from the features of the female, right? So that is how the points which we'll be plotting, if we plot it in a 2D plane or a n-dimensional plane, so the points will be separated, right? Will be separated. If they are not random data, they will be separate. Okay, the positive points will be clustered over some space, and the negative points will be clustered over some different space. Say there is some spam emails and non-spam email, right? So spam email will have some features which are common, right? And the non-spam emails will have some common features, so they will be clustered together, right? So let's say these negative points are some non-spam email, and the positive points are some spam email. So obviously the spam emails will have some features which will make them near each other, or which will make them common, and so they will be placed in the nearest neighbor, or they will make a cluster, right? So that is how we are separating it. Okay, that doesn't mean that some of the spam emails will also be categorized in the non-spam email. That what I mean by that is those spam emails are very much are alike the non-spam emails. So they actually are plotted near the non-spam emails. Okay, this is a real life example just to understand what I am talking about. Now what is this plane? This is basically a plane or a line which I want to plot. That is our goal, to plot this particular line or a plane. We'll be talking about plane because we want this to work as well in the n-dimensional space. So basically, just for simplicity, we are talking about the line that works in the 2D, right? So here what happens, you see, this line is what we want to find out. Okay, just you have seen, right, y equal to mx plus c. So this is an equation of a line in 2D. So we just want to find a line here which will separate the positive points from the negative points in the best possible way. Say, because there can be many planes, right? There can be many different planes which can separate this kind of points, right? Which we can draw. We can draw n number of lines, n number of planes, but we want the best one which separates them in the best possible way. Okay, so that is our goal, right? So now how there is an assumption in logistic regression, that is we want to have, okay, mx plus c. So we assume that the points are linearly separable or almost linearly separable. Okay, almost linearly separable. What does it mean? That means, you see, these points should not make a circle like structure. Okay, that is quadratic kind of structure, right? Circles, parabola, ellipse and all that. Linearly separable points can only be predicted or can only be separated by logistic regression. That is the first assumption which logistic regression takes into account. Okay, so it will only work if our points can be separated, if the two classes of points can be separated by some linear space. Okay, linearly they can be separated out, right? Now, for a plane, what is the equation? We already know for a plane the equation is, say for the plane pi, the equation looks like this: w transpose x plus b equals to 0, right? This is from linear algebra, right? W transpose x are the points which are provided, right? And b equal to 0. So what is w and b? W is nothing but the normal to the plane. Okay, this is w, and b is nothing but the intercept, right? B is nothing but the intercept. That is how distant it is from the origin. Okay, if I talk about a line, then how what do I mean by the intercept? Say this is 0 0, right? This is origin. So if our point if our line, say it passes from this like this, then this particular value, this distance, is nothing but the intercept term. Okay, we already know this from linear algebra, right? So this is the intercept term, and let's say for simplicity we assume that our line actually passes from the origin. Okay, so let's assume that our line passes through the origin. Then what will happen? We can make this as 0, right? Intercept is 0 because it is passing through the origin. So our equation is basically w transpose x equals to 0. So we'll be using this particular thing, okay, in order to derive the equation of logistic regression. Now what happens, you see? So here we have some positive points, we have some negative points, right? And now what do? Now we simply check what is the distance. You already know this from linear algebra, still I'll explain this distance. Okay, what is w? W is the normal to the plane, right? And we are assuming that w is a unit vector. Okay, so what is the distance of a point? Say this is xi, say this is a point called xi, positive point xi. Okay, so what is the distance? Let's say this distance is di, and let's say a distance of the plane from a negative point is dj, just for example. Okay, so what is di? Since di or xi here is a distance, or xi is a point which is on the same side where the normal is pointing. Again I would say, since xi is a point which is on the same side of the plane where this w is pointing, so this di will be positive. Okay, so this di will be positive. Okay, this is from linear algebra. How does it work? It actually works like this. So what is di? How do you find di? So I'll just write the equation: di equals to w transpose x by norm of w. Okay, this. Now let's assume that this w is an unit vector. So what will happen? This can be cancelled out, this can be cancelled out to 0, right? So this is w transpose xi by the norm of w. So what is di? Now di is basically w transpose xi, right? So this distance is greater than 0 if the point is on the same side of the plane where the normal is pointing. This is from linear algebra. Okay, because you see, for the computer we have no idea, or for mathematics we have no idea which are positive points, which are negative points. This is our assumption, right? We are saying the dog class is positive, the cat class is negative, the male class is negative, the female class is positive. This is what we are assuming. But for the computer or for the algorithm, they have no idea what a positive class or what a negative class means. They are simply two different classes, that's it. So how do you differentiate them? So we differentiate it in this way, that all the points which are on the same side of the plane where the normal is pointing, those points are actually positive points. Okay, and all the points which are on the negative side or on the other side of the plane, on which the normal is pointing to, so those points are basically the negative points. So dj, any dj will be less than 0. Okay, the values of the distances will be less than 0, right? Now given this situation, what we can use it for, right? So I'll just tell you how it works. See, we have some xi points, we have some yi points, right? So now let's see how it can be used to find to get different cases where we will see what our logistic regression algorithm actually talks about or actually finds out, right? So let's see how it works.